Okay, we're going to look at problem 17 in 1.6, and we're going to use elimination to find consistent solutions to this. And what we need to realize is consistent solutions don't mean that they need to be unique. And so in our case, if we watch the reduction of this matrix, we will see that we might get a parametric set of answers. We just have to guarantee that there is no inconsistency. And so the inconsistency will come up, and we'll see here as we turn this into a matrix and we row reduce. So in matrix form, I want to give myself some space for the B's. As Nicolas Cage would say, not the B's. Haven't seen that movie. I like the original so much. B3. All right, so I have a good pivot in the first row here. So I'm going to use that pivot. I'm going to take -4 times row 1 into row 2, and I'm going to take +3 times row 1 into row 3, and that'll be my first manipulation. So the first row does not change, and -4 times this zeroes that out. That's going to give me a +8, so that'll be 3. That'll give me a -20, so -12, and -4b1 plus b2. Now I'll do this manipulation. The 3's zero out. I get a -6 or a -3. I get a -12. Let me look at my signs here. 3 is 15. That's a +12. And I'm going to have 3b1 plus b3. And I'm not going to change the pivot here because I see that these are going to cancel out in the A coefficients. I'm going to add 2 to 3. Down here in the last bit of my screen. So the top doesn't change. And then when I'm done, I'll divide row 2 by 3. So I'll really quickly divide this by 3. I get 1. -4, -4/3 b1 plus 1/3 b2. But I'm still going to process adding these two rows. So that gives me a 0, a 0. And then a -4b1 plus 3b1 is -b1 plus b2 plus b3. This is going to end up being parameterized. I could solve it as a system of parameters right now by setting x3 to t, and then in solving across, that means I would have parameterization here. I could also clear the pivots here. So this is just in values of x2 and xt, and this is only in x1 and x2. But what's important here is for this to be consistent, my last row has to be 0, 0, 0. That implies that for this to be consistent, or b1 equals the sum of b2 and b3.